Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is AQA November 2022, Paper 3, Foundation Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1. What is the clockwise turn from north to east? Circle your answer. Okay, well I think it'd be easy to see this if we draw a picture. So let's just make a compass. Never eat shredded wheat. So we want to go from north to east. So if I start in this direction and I turn to this direction clockwise, I'm going from there to there then, aren't I? Well, that's just a 90-degree turn. See, as soon as you do a diagram, it's super simple. Question 2. D is 6 more than C. Circle the correct equation. Okay, so D is 6 more than C. D is 6 more than C. D equals C plus 6. It's got to be that one there. Question 3. Here is a number line. It goes from 2 to 3. It's got a few divisions in between. Which number is at A? Circle your answer. Okay, so when you want to understand scales, you need to know two things. You need to know the span, and this spans 1 unit, okay? And you need to know the number of steps, okay? So I've got 1, 2, 3, 4 steps, okay? So then each step is going to be the span divided by the step, isn't it? So if you take the span and you divide it by the step, in other words, I've got 1 over 4. That means each one of these steps is worth a quarter, which as a decimal is 0.25, then, isn't it? So it's going up in 0.25s. So this is going to be 2.25, 2.5, 2.75, and then 3. So that's the answer there, it's 2.75. Question 4. In the quadrilateral, which angle is obtuse? Well, acute is less than 90, isn't it? So acute is less than or equal to 90. Obtuse, that's like between a right angle and a straight line. So it's kind of between 180 and 90. And then reflex is, so between 180 and 360 is going to be your reflex angle. So what we've got here, we've got like a right angle, which is kind of between the two, acute and obtuse. We've got this one here, that's also less than a right angle. This one is more than a right angle, isn't it? So that one is going to have to be the obtuse one. So it's the angle at D. Now to label the angles in this notation we got down here, if you think about it, the label at D stretches from there to there, doesn't it? That's the angle we're talking about. Okay, so that's how we label them. We label it ADC. Okay, so this is the angle ADC. So the thing where the angle is in the middle. It's the middle letter. So the D is in the center, And then either side of it, you've got like where the arms are going. So it's going out to A and to C. Okay, that's how you label them up. Question 5a, write down two prime numbers between 25 and 35. Well, what could I have? Can I have 27? No, because that's divisible by 3 and 9. 29 is one, isn't it? So we could have 29. About 31. I think 31 is prime as well. If it is the calculator paper, there is a trick to work out if it's prime or not. You can use the prime factor decomposition button on your calculator. So if you press in the number that you think is prime and then press the prime factor decomposition button, if it just gives you your number back, then you know it is prime. Okay, so if I type in 31 in this case, press equals, and then ask it to be shown as prime factors, then I just get the answer 31 back. Okay, so if it's not prime, you'll get it broken down into smaller primes. But in this case, 31 is definitely a prime, so we can carry on. Write down one cube number between 100 and 300. Again, so like cube numbers, let's just think about what the cubes are. The cubes are numbers times itself. The smallest cube is 1 times 1 times 1, which is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. So the first one between 100 and 300 is 5 times 5 times 5. That's 125. And then 6 times 6 times 6 is 216. And I think 7 times 7 times 7 is already too big. So it's going to be those two then, isn't it? 125. Oh, I only have to do one. So I'm done already. 125. Question 6a. Here are two straight lines. Write down the size of angle W. Well, that's nice and straightforward. These are what we call vertically opposite angles, aren't they? So that one and that one are vertically opposite when you have two lines crossing like that. Vertically opposite. That's how you say it. And the thing about vertically opposite angles are that they are equal to each other. Okay, so that means W must be 43. Easy squeezy. Part B says here are two different straight lines. Work out the size of angle X. Well, this time we've got what we call angles on a straight line. That's a straight line, and we've got a line coming down and joining like that. Creates two angles. It's got 62 here and our unknown angle X. And angles on a straight line sum to 180 degrees, aren't they? So X plus 62 must be equal to 180. So then taking 62 away from both sides, that leaves me with X is equal to 118, I think. 6c, in a triangle, two of the angles are 51 and 74. Work out the size of the third angle. Okay, so we've got a triangle. I know that that's 74 and I know that's 51. And my unknown angle altogether with the other two must be equal to 180, mustn't it? Because angles in a triangle always add up to 180. So X plus 51 plus 74 must be equal to 180. So those two together, what do they make? So 51 and 74, that adds up to 125. So I've got X plus 125 is equal to 180. And then taking 125 away from both sides. Okay, and that leaves me with X is equal to, what's that, 55 degrees? I think so, 55. Question 7a, solve 12 minus E is equal to 0. Okay, well, if I've got 12 and I take E away and I get 0, then E must be the same size as 12 then, mustn't it? So E must be equal to 12, so E is 12. So 12 take away 12 is 0. Solve 7f equals 0. If I take 7 and I times it by f and I get 0, then f must have been equal to 0 to start with, isn't it? Because something times 0 is always 0. And the only way you're going to get 0 out of multiplying two things together if one of them was 0 to start with. Yep, so f is 0. Question 8. Put these probabilities in order, starting with the least likely. Well, least likely is the smallest fraction, isn't it? That's what it means, least likely. Probability is the closer it is to 0, the less likely it is. So in order to put these in least likely order, just need to rewrite them in all in the same way so we can compare them, can't we? So I think we're going to write them all as decimals. So 72% we know is 0.72. Just the first two digits of your percentage are the first two digits after the decimal point there. I might add an extra 0 on the end so it's the same size as that other one. So 0.720. It just makes it easier to compare if they've all got the same number of digits. And then 7/10, well, the tenths are the first decimal point, aren't they? So it's going to be 0.7. Again, if I just pad it out with 2 extra zeros, so it's a similar styling as the other two, that makes it much easier to compare. So 700 is less than 705, which is less than 720. So the smallest one then is going to be the 7/10. And then the middle one is the 0.705, and then the largest one is the 72%. Okay. Question 9. The x values in the table make a linear sequence. The y values in the table make a different linear sequence. Complete the table. Okay. So you can see with the x values, they are going up in twos. Plus 2, plus 2, plus 2, plus 2. So the next one is going to be 2 more than 8 then. That's going to be 10. And then the second sequence, the y sequence, that's going 3 to 7. That's plus 4, plus 4. So the next one is going to be 4 more than 11. That's going to be 15. And then plus 4, 19, plus 4, 23. And that seems to work. Okay, so we've done that part. So part B says draw a straight line passing through point 0, 3, 2, 7 and 4, 11. So the first 3 points on our table then. So 0, 3 along the corridor up the stairs, it's that point there. 2, 7. 2, 7 is here. And 4, 11. 4, 11 is there, look. Okay, so then taking a ruler, joining them up with a straight line. Gives us a line that looks a bit like that then, doesn't it? Okay. Part C says use your graph to work out the value of y when x is equal to 3. So x is 3 is this value down here, look. So what we're going to do is we're going to put our ruler going straight up from 3 until it hits the graph. Like that. When we hit the graph, we're going to change direction and head off to the y-axis in that direction. And you can see then my line points at the number 9, isn't it? Okay, so when x is 3, y is going to be equal to 9. Question 10a, when 5 is added to a negative number, the answer can be positive. Give one example to show that this is correct. Okay, so if I've got a negative number, like, I don't know, -2. If I do -2 and I add 5, then that takes me up to positive 3 then, isn't it? So that's one example of that being correct. So -2 is negative. I add 5 and I get positive 3. Okay? Now part B says, give one example to show that this is... Part B says, when 5 is added to a negative number, the answer can be negative. Give one example to show that this is correct. Okay, well, again, if I take something further down the negative number line, so let's take it down to maybe -9, and I add on 5, then it's not enough to get past 0 then, is it? It's still going to end up in the negative part of the scale. So -9 plus 5, that's going to take me to -4. Okay, so negative plus positive there, it remains negative, whereas before it became positive. And part C says when a number is doubled, the answer is always greater than the original number. Give one example to show that this is not correct. When a number is doubled, the answer is always greater than the original number. Well, if I take 0 and I double it, 2 lots of 0, I get 0 then. That's still the same number, isn't it? So that one hasn't increased. Okay. In fact, you could have 0. In fact, you can have any negative number, really, can't you? So if you take a negative number, 2 lots of a negative number, you're going to get a greater negative number, which is actually less. Okay, so -2 is less than -1, so either of those is fine. So either pick any negative number, or you can pick 0. Question 11. 480 people are asked if they eat sushi. Sushi. 20% say yes. 2/3 of the people who say yes eat sushi at least once a month. Complete the frequency tree. Okay, so 480 people asked and 20% of people say yes. What is 20% of 480? Well, 20% as a multiplier would be 0.2, isn't it? That's 20%. So if I take my amount, 480, and I multiply it by 0.2, then I'm going to get 20% of it. So 480 times 0.2, I believe that is 96. 96. So that means that 96 people eat sushi, which means that 480 minus 96 people don't eat sushi. That's 384 people. Now, of those 96 people who eat sushi, 2/3 of those people eat sushi at least once a month. So what's 2/3 of 96? 2/3 of 96. Okay, you can just do that on the calculator, or you can just divide through by 3 first. That gives me 32, and then times by 2, that's 64. So that means 64 people have it at least once a month, and 32 people do not have it at least once a month. There we go, it's all done. Question 12, event A has taken place every 4 years, and event B has taken place every 3 years. Both events took place in 2019. Work out the last number before 2019 when both events took place. We have to kind of work backwards here, don't we? Okay, so if we're going back in 4 years from 2019, I've got 2019, subtract 4 would be 2015, and then I'm going to get 2011, and I'm going to get 2007 and 2003 and 1999. I think that would do. I'm going to switch to the other one. I don't know how far back I need to go. So again, going back in 3, so that's in 4 years. In 3 years, that's going to be starting with 2019. Going back 3 years will be 2016. Going back 3 years is 2013. Going back 3 years is 2010. And going back 3 years is 2007. I've seen that one before. There it is, look. So those two go together. Okay, so the last time these events took place in the same year was going to be in 2007. Question 13. Luke wants to make a number machine so that y equals 5x plus 3. Here is his attempt. So he's putting x in the number machine, he's adding 3 and then times them by 5 and getting y. What mistake has he made? Well, he's not going to get 5x plus 3 here. He's going to be adding 3 first. That will give him x plus 3, and then he's multiplying it by 5. So he's actually written down the function machine for y equals 5 lots of x plus 3. Not quite the same thing. So what he's done is he's got these the wrong way around, isn't he? He should have been multiplying by 5 first and then adding 3. Okay, so the mistake he made is he added and then multiplied when he should have multiplied by 5 first and then added 3. Okay. Question 4. Circle the solid that has 6 edges. Is it a triangular based pyramid, a sphere, a cube, or a cylinder? I think with these sort of things, it's easiest to draw it, okay, and then count the number of edges that you've got. So a triangular based pyramid. So if I've got like a triangular base coming up to a point, how many edges is that? That's 1, 2, 3, 4, 5, 6. So that's got 6 edges. A sphere, well, sphere doesn't have any edges. Or does it have 1? I don't know. I think it hasn't got any. I think that's 0 edges. A cube, okay, so you've got like 1, 2, 3, 4 in the front face, 1, 2, 3, 4 in the back face, that's 8, and then 1, 2, 3, 4 in between. So I make that a total of 12. And then the cylinder has got 1, 2, no, it's just got 2, isn't it? It's got this edge around here and this one. So that's got 2. So the only one with 6, look, is that one there. It's going to be the triangular based pyramid. Question 15a. On the grid, shape A is shown. One side of shape B is shown. Complete shape B, so it is congruent to shape A. So congruent means exactly the same shape and size. So there's only one length, which is length 3 on this diagram. It's that side there. So that's got to be that one there. So you could have seen that this shape is rotated round. So completing the shape, just going to have another kind of L shape here. Just going to draw the horizontal lines first because my ruler is a little bit fiddly to turn. Okay, and then I'm going to spin it around and draw the other ones. Okay, so there's my L-shaped B, and let's call it B. Now, you could have had it in any other orientation as well. You could have drawn it this way up, or you could have drawn it the other way around, like this. Doesn't really matter because you can flip shapes over and they can still be congruent. Okay, so as long as it's another L shape and that is alongside any other orientation you can get from that is fine. On this grid, for part B, on this grid, shape C is shown. One side of shape D is also shown. Complete shape D so that it's an enlargement of shape C with a scale factor of 2. Okay, so again, let's see if we can find the matching side first. This is of length 6. If it's twice as big, its matching one must be 3, and there's only one 3 on there. It's got to be that one there. Okay, so that's the long side. Now, in order to draw this a shape, I want to work out where this corner is first, and then I can just finish it off, can't I? So to get from there to there, I'm going like 1 square along and 2 down. Now, if I'm enlarging this with a scale factor of 2, it's going to be twice as far from one corner to the other. So rather than going 1 to the right, I'm going to go 2 to the right. And rather than going 2 down, I'm going to go twice as far. I'm going to go 4 down. So that corner there is going to be at that point there. Okay, and once I've worked out where the corner is, it's quite easy to finish this off. Then I just need to draw those lines in between. Okay, so I'm going to have a line from there down to there, and one from there to there. Okay, there's my enlarged shape. It should look bigger than the original one. Let's just call it D for completion. Yeah, it should just look like the same shape but bigger. Use your eye and inspect it because your eye is quite good at spotting these things. Question 16. 40 students were asked the number of visits they made to a gym once a week. The chart shows information about the results. Okay, so we've got number of visits along the bottom, number of students up the side. Write down the modal number of visits. Now, mode means most. Okay, so when we're talking about mode from a bar chart or a line graph like this, it's the one with the tallest line. It's going to be this one here, isn't it? It's going to be 1. 1 is the tallest line, so 1 is the modal number of visits. Work out the mean number of visits. Give your answer as a decimal. Okay, so the mean number of visits is the total number of visits divided by the total number of students. Okay, so in order to work this out, though, it's not quite as straightforward. I think I'm going to have to make a little bit of a frequency table first. So if I make visits, students first, let's just kind of flip it into a table. So 0 visits was 7 students, that's the height of the first bar. One visit, that's the second bar, that's got a height of 10. 2 visits is 8. 3 visits is 7. 4 visits is 5, and 5 visits is 3. Okay, so that's kind of like a frequency table. The total number of students being 40, if I add them all up, should add up to 40. Now, to get the total number of visits to the gym, 0 times 7 is 0, 1 times 10 is 10, 2 times 8 is 16, 3 7s are 21, 4 5s are 20, and 5 3s are 15. So what does that add up to? 10, 26, 46, 47, 67, 77, 82, I believe. So that comes to 82. So therefore then the mean is going to be the total visits made, which is 82 divided by the total number of students, which is 40. So 82 divided by 40. 82 divided by 40, that comes to 2.05. 2.05. And part C says one of the 40 students is chosen at random. Work out the probability that the student visit the gym at least once. Right, at least once is everybody apart from 0, then, isn't it? So how many people did it at least once? Well, 7 people visited not at all. So if I take those away from 40, that leaves me with 33 students went at least once. Okay, so then the probability of at least once is going to be those 33 students divided by the 40 students in total. So it's going to be 33 over 40. Question 17. This scale drawing of a bus has length 8 centimeters. And we're told that the scale of 1 centimeter represents 1.65 meters. The actual length of the bus is 3.8 times the actual length of a car. Work out the actual length of a car. Give your answer in meters to the nearest centimeter. Okay, so we've got the scale. Let's start with the scale first. We've got the scale of 1 centimeter represents 1.65 meters. So if 1 centimeter represents 1.65 meters, then our 8 centimeters of the bus is going to be 8 times bigger then, isn't it? If I'm going to times that by 8, I'm going to have to do the same here as well. So what's 8 times 1.65? 8 times 1.65, that comes to 13.2. So the bus must be 13.2 meters in length. Okay? Now, we're told that the actual length of the bus is 3.8 times the actual length of the car. So car to bus is in the ratio of 1 to 3.8. Okay? So if we're going from 3.8 up to 13.2, what have we scaled up by a factor of then? What's the multiplier there? To find that out, I'm going to have to divide, aren't I? I'm going to have to divide one by the other. So if I divide 13.2 by 3.8, that gives me like 3.47 and change. I'm just going to round it off to 3.47. 3.47. So if I've multiplied that side by 3.47, I'm going to have to do the same thing on this side. Times 3.47. 1 times 3.47. That is 3.47. Okay, so that means that the car needs to be 3.47 meters in length. Okay, I've already rounded off to the nearest centimetre, so that's my final answer then. 3.47. Question 18. 11 identical full tins of red paint hold a total of 3,630 millilitres. All the paint from 4 of these tins is poured into an empty bucket. The bucket can hold 2,500 millilitres. Tins of white paint each hold 140 millilitres. Can all of the white paint from 9 tins be added to the bucket? You must show your working. Okay, so there's quite a few steps in this one, isn't there? Okay, I think the first step is to look at this bit at the top here. I know that 11 identical full tins hold 3,630 millilitres. So from that I can work out how much one red tin contains. So one red tin is going to be the amount of paint that's in 11 of them divided by 11, then, isn't it? So what is 3630 divided by 11? 3630 divided by 11, that comes to 330. Okay, so there must be 330 millilitres in one red tin of paint. Okay, so that came from there then, that's that bit. And then so the next bit says all the paint from 4 of these is poured into an empty bucket. Red paint in bucket, that is going to be 4 times 330 then, isn't it? So it's our answer from here, that one, times the 4 we got from the question. So 4 lots of 330. 4 times 330, that comes to 1,320. So let's just write that down. 1,320 millilitres of red paint in the bucket. Now, next up, we are told that tins of white paint hold 140 millilitres, and there are 9 tins. Well, we want to know if we can fit 9 tins worth in. So let's find how much white paint in bucket, if it fits, is going to be 9 lots of 140. Okay, so we've got that all from the question. So what is 9 times 140? So 9 times 140 is 1,260. So we're attempting to put 1,260 millilitres in the bucket. So total paint then that we're trying to add is going to be those two added together, isn't it? It's going to add those two together. So 1320 plus 1260. I can see already that's going to be too much, but let's just add it up. So that comes to 2580 milliliters. Now that is more than the amount of space in the bucket then, isn't it? I know that 2580 is bigger than 2500. So can it fit? No. Can't fit in a bucket. Okay, can't put that much paint in the bucket, it's going to overflow. Question 19, the largest possible value of n is 2. Circle the correct inequality. The largest possible value of n is 2. That means all the values of n must be 2 or less. So it's that one, isn't it? So n is less than or equal to 2. It's that one. Question 20, Jamil is on holiday in France. Part A says the cost of a room in a hostel is 27 euros. Convert the cost to pounds. Use £1 is 1.2 euros. Okay, so we're going from the many to the one here, aren't we? We're going that way round. So when we're going from the many one to the one, we're going to divide. If we're going from the one to the many, we multiply. If we're going from the many to the one, we divide. Okay, so the cost in pounds is going to be the 27 euros divided by 1.2 euros, and that comes to 27 divided by 1.2, and that comes to 22.5, I guess, which is £22.50, isn't it? Should really write that in pounds and pence. Part B says Jamil rides a motorbike. The motorbike uses 1 litre of petrol for every 14 miles. How many litres of petrol does the motorbike use to go 168 kilometres? Use 8 kilometres equals 5 miles. Okay, so this amount is in miles, but we've got the distance in kilometres. But we've also got the ratio of kilometres to miles here. So I'm going to use the ratio of kilometres to miles first to convert kilometres into miles. So miles is going to be equal to the 168 kilometres, and we're going to divide that by 8, and we're going to times it by 5, okay, to convert from kilometres into miles. So 168 divided by 8 and then times by 5, that's equivalent to 105 miles. Okay, now miles are longer than kilometres, so you should get less miles compared to kilometres. Okay, so that's 105 miles. So now we know the number of miles, and we know that the motorbike uses 1 litre of petrol for every 14 miles. We can then work out the amount of petrol required then. So petrol required is going to be the 105 miles that we need to travel divided by the 14 miles it can do on every litre. So what's that then? 105 divided by 14, that's 7.5. So we require 7.5 litres then. Okay, that's the answer, 7.5 litres. Question 21. The scatter graph shows the height and mass of some dogs. Part A says the scatter graph shows positive correlation. Describe the relationship between the height and the mass of the dogs. Okay, so we can see with the ruler then that our values are broadly going up underneath the ruler, aren't they, in an upward direction. So it's definitely positive correlation, but that's not what this is asking for here. It's asking for the relationship. And when you ask for the relationship, you don't need to mention positive correlation. It's not positive and negative. It's as one increases, so does the other. So I'm going to say mass increases as height increases. Okay, if it was negative correlation, you'd say mass decreases as height increases. Okay, so they'd be inversely proportional. But that's all you need to write down here. Mass increases as height is increasing. Use a line of best fit to estimate the mass of a dog with height 48 centimeters. Well, the first thing we need to do here is add the line of best fit because we haven't got one. So using our ruler, just kind of line up through the points. So you kind of got an equal number of points either side of the line. I think about kind of there-ish. Okay, it's not an exact science. You will get marked on your own line that you draw. Okay, so as long as it's vaguely through the points like that, you should be all right. So that's my line of best fit. And I want to work out the mass of a dog with a height of 48 centimeters. So I'm going to find 48 on my scale. 45, 5 divisions, so 48 is here, look. I'm going to read up to the line and across like we did earlier. So reading up from 48 until I get to the line, and then I'm going to change direction and read over. It's a 2-mark question. It's good to show method when you've got questions like this. Okay, so and then I can see then I'm ending up here. Now there are 5 divisions between 20 and 25, so each one of those must be 1. So I'm making that 21 kilos. Question 5, ABCDE is a pentagon. Yes, it is. Work out the area of the pentagon. Well, you can consider this pentagon to be made up of 2 shapes. You've got like a trapezium part here, which I know how to work out the area of, and I've got a triangular part here. It's a right angle triangle, so I should be able to work out the area of that too. Okay, so I'm going to call this one area 1, and I'm going to call this one area 2. I'm going to work them out separately, and then I'm going to combine them together to find the total area. Okay, so area 1 first up, that is a trapezium, and the formula for trapezium is a half, open brackets, a plus b times h, where a and b are 2 parallel sides and h is the distance between them. So in this diagram, a is going to be 14, and b is going to be the side parallel to that. It's going to be that one there, 20, and then h is going to be the distance between them, so it's that one there, the 11. Okay, so subbing that into the calculation or into the formula, I've got a1 equals a half a, which is 14, plus b, which is 20, times h, which is 11. Basically, when you're doing this, you're kind of averaging out your 2 parallel sides, aren't you? Add them together and divide by 2. So what's the average for your 2 parallel sides? What's the average of 14 and 20? Well, 14 plus 20 is 34. Divide by 2, and they average out to be 17. So you can average out the 2 sides to be 17, and therefore the area is just 17 lots of 11. So what's 17 11s? Well, 10 17s is 170. So 11 17s is going to be 187. Okay, so that's A1 done. That's the trapezium. Okay, so let's move swiftly on. Let's have a look at A2, the blue one. Now A2 is a triangle, and the formula for the area of a triangle is just half base times height, where base and height, they don't necessarily have to be the bottom line and the one going up. They're just the 2 lines that are perpendicular to each other. So in this case, it's going to be 7 and 10, isn't it? So it's going to be half times 7 times 10. Half of 10 is 5. 5 times 7 is 35. So area 2 is 35. So then the area of the pentagon is going to be area 1 plus area 2, which is 187 plus 35. What's that then? 187 plus 35, 192, 222. 222, what's the units? Centimeters squared, isn't it? Okay. 222 centimeters squared. Question 6. Joe, Kim and Lisa each have an amount of money. Joe has £72. Joe's amount to Kim's amount is in the ratio of 6 to 5. Lisa's amount is 1.5 times Joe's amount. Show that in total they have less than £250. Okay? So we know Joe. Joe is 72, and we also know everybody else is relative to Joe's, because Joe's amount to Kim's amount is in the ratio of 6 to 5. Okay, so let's start with that one then. So Joe to Kim is in the ratio of 6 to 5, but we know that Joe is 72, okay, which is how many times bigger than 6? 6 goes into 72 12 times. So if I times that up by 12, I get 72. So if I times this one up by 12, 12 lots of 5, that's equal to 60. So I make Kim's amount then equal to 60. Okay. And then Lisa's amount is 1.5 times Joe's amount. So what is Lisa's amount then? So this was for Kim. And now we're on to Lisa. So Lisa is going to be Joe's amount, which is 72, times 1.5, isn't it? Okay, so 1.5 lots of 72, you could type it into the calculator, but it's just 1 lot of 72 plus half of 72. So half of 72 is 36. Add it on to 72. That's 108 then, isn't it? So Lisa's is 108. So altogether then, Joe's plus Kim's plus Lisa's is going to be 72 for Joe, plus 60 for Kim, plus 108 for Lisa. What does that come to? That's 168, 170, 240 then, isn't it? So they add up to 240, which is less than 250, isn't it? So total is less than 250. Okay, so we've kind of done it. Question 24. A solid statue has volume of 512 cubic centimeters. The statue has mass of 3.6 kilograms. And we're told that density of iron is 7.87 grams per cubic centimeter. Is the statue made of iron? You must show your working. Okay, so we've been given the volume and the mass of this statue, and we know the density of iron. So if we can work out the density of the statue and compare it to the density of iron, if they're the same amount, then, you know, it must be made of iron, mustn't it? Okay, so, well, it's a good indication that it's made of iron. So what is the relationship between density, mass and volume? Well, luckily we've got like a handy triangle to remember these things. So density, mass, volume is a bit like that. So density equals mass equals volume equals. Okay, so we don't yet know the density. Okay, we want to compare it with 7.87, but we don't know the density of this statue yet. Okay, what's the mass? The mass we said was 3.6 kilograms. Okay, and then the volume, what's the volume? The volume is 512 cubic centimeters. Okay. So then, covering up the thing I want to find density. That's mass divided by volume then, isn't it? So density equals mass over volume, which in this case is 3.6 kilos divided by a volume of 512. Now, actually, before I do that, just noting the fact that this is in grams per cubic centimeter, and currently this is in kilograms. So before I do this division, actually, I've decided I'd probably be better off to change that unit first. So what is that in grams then? That's going to be 3,600 grams, isn't it? Okay, so I'm going to use that so that I'm ending up in grams per cubic centimeter rather than kilograms per cubic centimeter. So 3,600 grams divided by 512, so 3600 divided by 512, that comes out to be 7.03. So I make that 7.03, okay, which is not 7.87, isn't it? It's a lot lighter than what iron would be. Okay, so I'm going to say the statue is not made of iron, as 7.03 is not equal to 7.87. Okay. Question 7a. Here is the rule for a sequence. After the first two terms, each term is the sum of the previous two terms. Okay, so it's a little bit like a Fibonacci sequence. The first term is 33, the second term is x, the fourth term is 73. Work out the value of x. Okay, so we know that u1 is 33, and we know that u2 is x. So then u3 is going to have to be the sum of those two then, isn't it? It's going to have to be 33 plus x. And then u4 is going to have to be the sum of u2 and u3. So it's going to have to be x plus 33 plus x. In other words, it's 2x plus 33. Okay, but we've actually been given the value of the fourth term in the question. We've been told it is equal to 73. So this expression over here, u4, has to be equal to 73. So that means we can form an equation in x that we can then go on to solve then, can't we? So if I know that 2x plus 33 is equal to 73, then I can just solve for x, taking 33 away from both sides, minus 33 minus 33. They'll cancel, just leaving me with 2x. And then 73 take away 33 is 40. So then dividing both sides by 2 then. That's going to give me 2x divided by 2 is x. And 40 divided by 2 is 20. So that's my answer then. X is equal to 20. Question 7b. An expression for the nth term of a different sequence is n minus n squared. Ruth says all of the terms will be negative because n squared is always greater than n. Is she correct? Tick a box. Well, she's almost always correct, apart from when n is 1, I guess. So she's not always right, because when n equals 0, then n minus n squared is going to be 0 minus 0 squared, which is equal to 0. And I don't think 0 counts as a negative number. 0 is not negative. Okay, it's a kind of in between, isn't it? 0, it's neither positive nor negative. Okay, so not negative. Question 9. P and Q are points. The x coordinate of Q is 4 more than the x coordinate of P. The y coordinate of Q is 5 less than the y coordinate of P. Work out the gradient of the straight line through P and Q. Okay. Now let's create a general point P which has got coordinates x and y. So if that's my point there, then I know that Q is 4 more than P in the x direction. So it's going to be like 4 units in that direction, isn't it, away from P. And its y coordinate is 5 less than the y coordinate of P. So I'd have to be going down 5 to get to Q. So Q is going to be down here somewhere, isn't it? So that's going to be Q with x coordinate x plus 4, because it's 4 more than P, and y coordinate y minus 5. Okay, I don't really need that actually. I can just use the triangle actually to solve this, can't I? So if you think about it, we want the gradient of this line here, and gradient m is equal to change in y divided by change in x, isn't it? Okay, so here change in y is 5 and change in x is 4. Don't forget though that this line is sloping downwards from left to right, so you could consider that to be -5 rather than +5. So this gradient is going to be negative overall, so it's going to be -5/4. Question 27. M equals PR. P is halved and R is multiplied by 3. What happens to M? Okay, so if we take our value in P and halve it, then M is going to be halved. So we're going to be dividing by 2. And if we multiply R by 3, then M is also going to be multiplied up by 3. So we're going to end up with that then, aren't we? 3 over 2. It's going to be that one there. Question 10. Here are the results after 250 spins of a coin. Now it landed on heads 128 times and it landed on tails 122 times. The coin is spun an extra 50 times. After all 300 spins, the relative frequency of heads is 0.49. For the extra 50 spins, work out the number of heads to the number of tails. Okay. So overall, the relative frequency of heads was 0.49. So then the number of heads in total that were achieved is going to be the 300 trials times the relative frequency of success. It's going to be 300 times 0.49. That's basically going to be 3 lots of 49, isn't it? It's going to be 147. So 147 heads altogether. So there are 147 heads altogether. So the number of new heads is going to be the number of heads altogether minus the number of old heads, which was 128. What's the difference then? So there must have been another 19 heads then in the last 50 trials then. So then the number of heads to tails then in the last 50 in final 50. Heads to tails is going to be, well, they're going to be 19 heads, and then how many tails is that then? So the rest of it would be tails. So it's going to be 50 minus 19, and that's going to be 31 tails. Okay, so I had a bit of a run of good luck on tails in the last 50 then. Okay, so 19 heads altogether and 31 tails in the final 50. Question 29, circle the equation where C is inversely proportional to D. Well, if C is inversely proportional to D, then we're going to have D on the bottom and C on the top like that, which means C is going to be equal to some constant divided by D. Okay, so which ones look like that? It's got to be that one there. That's the only one with D on the bottom with D as a single power. This has got D on the bottom but it's squared, so that one isn't right. And the other two have got D on the top, which means that they would be proportional to, not inversely proportional to. Okay, so it's going to be C equals 2 over D. Question 11. Part of a running track is the arc of a semicircle joined to a straight line. The semicircle has a diameter of 45 meters. The straight line has a length of 75 meters. Abby runs once along this part of the track in 18 seconds. Work out her average speed. Give your answer to 2 significant figures. Okay. Now, we know average speed. Well, we should know average speed from the DST triangle, DST. If I want to work out speed, then it's going to be distance traveled divided by time taken. So average speed equals distance traveled divided by time taken. Okay, so do we know any of those things? Well, we know the time. We know t is equal to, so we can sub 18 in straight away, and that's the time taken, then, isn't it? T is equal to 18. Okay, but what about the distance traveled? We don't know that yet, do we? So we need to work out what that distance is before we can work out the average speed. Okay, now the distance traveled is going to be a combination of this part of the track, okay, which is an arc, plus this part of the track then, isn't it, which is a straight line. Okay, well, the straight line is easy, it's 75. What is the curved part going to be? Well, it's half of the circumference of that circle. Now, we know that the diameter of the circle is 45, and I know that the circumference of a circle is pi times its diameter. Okay, but we've got a semicircle, so our arc length is going to be half of that, then, isn't it? It's going to be pi times diameter over 2, because it's half of a circle. Okay, so we know that the diameter is 45, so it's going to be 45 pi over 2. So that's the arc length, and so then the total distance traveled is going to be the arc, which is 45 pi over 2. I'm just leaving it in terms of pi for now, just to maintain accuracy, plus the straight section, which is 75. Okay, so this is the curved part, and this is the straight part, and altogether that is going to give me the distance. Okay, so then the distance traveled then is going to be whatever that is divided by 18. Okay, so I'm just going to work out what that is now then. So what is 45 pi over 2 plus 75? So 45 pi divided by 2 plus 75. That comes to 145. I'm just going to round it off to 145.7. 145.7. And so I'm going to then divide that distance then at that 145.7. Needs to go in here then, doesn't it? 145.7. That's what I'm going to be dividing by 18. Now, it wasn't quite 145.7. I've got the full amount on my calculator, and that's actually the amount I'm going to use. I'm not going to divide 145.7 by 18. I'm just going to take my last calculated value, which is the big long decimal, and divide that by 18 to retain accuracy as I go along. Otherwise, your answer kind of diverges from the true answer if you keep rounding off mid-calculation. Okay? Right, so that comes out to be 8.0936. Now, I need to round this off to 2 significant figures. So that is equal to, I'm going to have to round off after the 0. Next digit is 9, which means I round up. So it's going to be 8.1 to 2 significant figures then, isn't it? Okay. Question 8. Here is some information about members of clubs A and B. Club A, number of members is 24, and the mean height of the members is 1.8. Club B is a club for giants. There are 20 of those, and the mean height is 1.92 meters. Work out the total height of members in Club A divided by the total height in members of Club B. Give your answer as a decimal. Okay. Well, the total height then we can easily get by multiplying those two together then, can't we? So if I take the number of members, 24, and multiply it by the height of 1.8, I'm going to get the total height for Club A, and similarly for Club B. So what is 24 times 1.8? 24 times 1.8, that comes to 43.2. 43.2. And the 20 members of Club B with a height of 1.92 comes to 38.4. Okay, so then the total height of members of Club A, 43.2, divided by the total height of members of Club B, 38.4. What's that then? So 43.2 divided by 38.4. That comes to 9 over 8, which is 1.125 as a decimal. 1.125. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.